When you're in school, you're taught sine of x, cos of x, and tan of x. As you get older, you will be taught cosecant. So normally, looking at this triangle, normally this is sine. Well, going the other way would be 1 over, remember this height here is sine, this base here is cos. So going the other way would be cosecant. So you will be taught this as you get older. And normally this is tan, but then going the other way would be cosine over sine. That's what cot is, cotangent. And then normally this is cosine, and then going the other way would be secant of x, which is this. My point is that given any of these trigonometric functions, you can always sketch the graph by using some of the methods we developed earlier. So for example, let's try and sketch this graph randomly. Select this graph. Secant of x. So secant of x is 1 divided by cos. So you can imagine our unit circle. As the dot moves around, what happens to this quantity, this fraction? Well, cos of x is the base of the triangle. So when it's at 90, there is no base because it's directly above the origin. There is no base. So you're in effect dividing by 0. So dead on 90, you know it breaks down. So at 90, which is somewhere around here, you know there's going to be a gap. And then as the dot moves around, by the time it gets to 270, you know you're going to divide by 0 again. But when the dot is here, there is no width on the triangle, on the base of the triangle. There is no width. So at 270 it breaks down. Now going the other way, negative 90, which is right here, you know it breaks down. And then negative 270, you know it's going to break down at negative 270. So you know the graph will have a vertical asymptote at these 4 points. Now let's investigate what happens when it's at an angle of 0. So when the dot is here, it will secant, which is what we're trying to investigate, would be 1 divided by the base. Or what is the base of this triangle when the dot is right here? Well, the base is 1, so you're going to have 1 over 1. So imagine this here is 1. So at 0, it would be right here. And let's dead on 90, it breaks down. Let's investigate what happens when it's just before 90, so it's just to the left of 90 degrees. Well, this quantity, secant, will be 1 divided by the width of that triangle. Well, when it's just before it gets to 90, you know that it's going to be a tiny width because the dot is here. If the dots were to be over here, then the width would be quite large. And then as it moves closer and closer, you can see the width gets smaller and smaller. Just before 90 degrees, the width will be tiny. So imagine it to be this number, really small. So now 1 divided by a very, very small number, I've already explained that this quantity would be very, 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 very big. So just before 90, you know it's going to jump up here. And then just past 90 degrees, is going to be 1 divided by the width. The width would be tiny, would be very, very small. Let's just imagine it's this. But don't forget, it's on the left-hand side, so it's going to be a negative. So this 1 divided by very, very small would be very, very big with a negative in front. So it's going to be negative, very, very big. So just past 90 is going to be very, very negative big, somewhere down here. Now let's look what happens when it's at 180. So here you got 1 divided by, what's the width at 180? It would be negative 1. It would be negative 1. So this here would be negative 1 divided by negative 1 would be negative 1. So imagine this is negative 1. And then down on 90 it breaks down. Let's investigate what happens just before 270. So it would be 1 divided by the width. The width would be negative, very, very small. So imagine it to be something like this. So don't forget, the width here would be this quantity here. very, very small, but negative. Now 1 divided by very, very small would be very, 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 very big, and it's a negative big. So just before 270, which would be right here, just before that, it would be very, very big. And then you can use the same argument. It turns out that the secant graph will look something like this, and then something like this, and so on. So you can slowly figure out any of these things by just investigating what happens as the dot moves around. Okay.